Welcome back to P3. Today we're looking at solving trigonometric equations, and this is unit 4.4. So this is looking at using the addition formulae and the double angle formulae, as well as what you already know from previous things like sine squared plus cos squared equals 1 to help you find or solve trigonometric equations. Let's jump straight in. So for an equation like this, the first thing I need to be thinking about is I've got my equation, but this part is the important bit. We need to get rid of that theta plus 30, and we want to use our addition formulae. So now the sine theta plus 30 is a plus b, so that's sine theta cos 30 plus cos theta sine 30. And you should know what 30 degrees is for cos and sine. So for cos it's root 3 over 2, and for sine it is a half. Now I can multiply by 8, giving me 4 root 3 sine theta plus 4 cos theta. Next step is to take my cos to one side. So taking away 4 cos gives me negative cos theta equals 4 root 3 sine theta. Now I need to make it a single trig identity. So I can do that by dividing by cos. And sine theta over cos theta is tan theta, and dividing by my 4 root 3 there. Now at this point I need to find out what theta is, and what I prefer to do is to find out the positive value of theta first. So I'm doing inverse tan of 1 over 4 root 3, and that will give me 8.21 degrees. Now we went from 0 round to 360 degrees, and tan is negative. As we can see here, tan is negative. So we're looking in this section and this section. So values of theta are 180 minus 8.21 and 360 minus 8.21. So those are my two possible solutions. So we have 171.8 degrees and 351.8 degrees. And if you want to be sure, just substitute one or both of your thetas into your original equation. Okay, when approaching this kind of question, you need to have a look at each of your terms. So we've got a sine squared 2 theta, cos 4 theta, and a sine 2 theta. So looking at this one seems the most likely one to change, because it's a double angle. The 4 theta, if I deal with a double angle, I will get something out with 2 thetas in it. And I want to change it into just something in terms of sine. Remember that cos 2a equals 1 minus 2 sine squared a, where in this case a would be 2 theta. So let's write it out. We've got sine squared 2 theta minus 1 minus 2 sine squared 2 theta equals 2 sine 2 theta. So sine squared 2 theta minus 1 plus 2 sine squared theta minus 2 sine 2 theta equals 0. So expanding the brackets and collecting everything onto one side. So we have 3 sine squared 2 theta minus 2 sine 2 theta minus 1 equals 0. Now at this point you can think of this in terms of y if you prefer. Let y equals sine 2 theta, and then you would be solving this equation, or you can just go ahead and straight solve it here. You know, we know it's quadratic with the squared term, the single term and the constant, but I know some people aren't as confident jumping straight in to what I'm doing just with the signs, and they prefer to do it how they've done it over the years, which I've written in black here. So it doesn't, like I said, it doesn't really matter which way around you do it. It's just important that you pick whatever you're more comfortable with and solve it that way. So we've got 3 sine 2 theta plus 1 equals 0, or sine 2 theta minus 1 equals 0. So sine 2 theta equals 1, or sine 2 theta equals minus 1/3. And then I need to solve then for both of these. And you can see if I carried on with the way I did it in black, we get 3y plus 1 equals 0, y minus 1 equals 0, y equals 1, y equals minus 1/3. And then since we know that y is sine 2 theta, you just substitute that in. So either method would be fine there. Now, because we've got a 2 theta, we do need to change our range, our domain, sorry. So we've got theta is between 0 and pi. That would mean that 2 theta is between 0 and 2 pi, as we'd need to multiply them by 2. Okay, and I'm going to use this as just x. So I'm just going to say let x equals 2 theta. So I got sine x equals minus 1/3, or sine x equals 1. And I prefer to do it this way, as I find that most students who do it this way don't make mistakes, whereas a few of the students that keep it in the form 2 theta will often make a mistake when they're finding their additional values. Now, just thinking of the cast rule for both of these, over on the side here, and like I've said before, I like to just put in the positive value for here to find this angle. Just I find it makes it so much easier. So inverse sine of 1/3 is 19.5 degrees, and that is that angle there. We want minus 1/3, so we're looking at minus sine. So we're looking at this section and this section. So my values of x are going to be 180 plus that 19.5. And then over here, 360 minus 19.5. So that gives me two angles, 199.5 and 340.5. Now looking across to the other one, sine x equals 1, we should know what that is, and we should know it's only going to happen when x is 90 degrees, between 0 and 2 pi. Now I've done all my angles here in degrees, but obviously up here is in terms of radians, so I should have perhaps done this all in terms of radians straight away, but equally I can just convert all of these into radians at the end. It's not an issue. And this would give me, for my three answers, x is pi by 2, and then 3.48 and 5.94. Okay, So that's one way of doing it, just doing it with degrees first and then switching it into radians. Remember, to do this, to go from degrees into radians, we would be dividing by 180 and multiplying by pi. I'll do this again just in fully in degrees, fully in radians. So here we would get 0.3398, and then it's pi plus 0.3398. Of course, I would use the full value of this, and 2 pi minus 0.3398. Again, using the full value of your calculator. And that, of course, will give me my 3.48 and my 5.94, as I've already found. And then, of course, over here on the right, we know this is just pi by 2. This is 180 divided by 2. So you can go straight in terms of radians or in terms of degrees. Exam questions, the mark schemes will always allow you to obtain almost full marks if you did it in degrees. So if you did it in degrees and didn't change to radians, you should still be able to obtain everything bar the final accuracy marks there. And they usually say, if you look at some of the past paper questions, you'll see in the mark scheme saying award the marks if they've done it in terms of degrees. So you can do it in terms of degrees and switch to radians, or you can do it in terms of radians from the start. Totally up to you. You just need to do what you're more comfortable doing. Now I'll give you a few to try. Okay, looking at this one, we've got cot, which we know is 1 over tan, and we've got cos and sine, which means if I divide by cos, this will also be tan. So I can turn this whole thing in terms of tan. So first I'm going to divide by the cos. And then we're going to deal with this cot. So I'm just going to remind you what tan A plus B is. Here it is. Now cot will be the inverse of that, like so. So that's what I'm going to use now in my equation. So my cot theta minus 45 is 1 plus tan theta tan 45 over tan theta minus tan 45, and that is equal to 3 tan theta. Now you should know, or should remember, that tan 45 is just equal to 1. So this is equal to 1 here, and this is going to be equal to 1. So on the top I've just got 1 plus tan theta, and on the bottom I've got tan theta minus 1. Now what I want to do is multiply up by this tan theta minus 1, multiply through, so that I can get these on one line and solve it. So we have 3 tan theta times tan theta minus 1 equals 1 plus tan theta. So that is 3 tan theta squared minus 3 tan theta minus 1 minus tan theta equals 0. So 3 tan squared theta minus 4 tan theta minus 1 equals 0. Now when we get a problem like this where we can't factorize, what we need to do is use the formula. So if we're thinking of the quadratic formula, A would be 3, B would be 4, and C would be -1. And when I substitute these in, I get that tan theta is equal to 2 plus root 7 over 3, or tan theta equals 2 minus root 7 over 3. I'll just make some room to finish this question. So here we've got that theta is equal to 57.1 degrees, and this one is minus 12.1 degrees. Obviously we don't want that minus answer, but we'll use it in our cast method in a moment. So looking at the first one, we want when tan is positive, so we want these two sections. So second answer here is 180 plus 57.1. So my values of theta for here are 57.1 degrees and 237.1 degrees. So looking at the other angle, 12.1 degrees will be that positive bit, but we want when tan is negative, so we want these two sections. So we're looking at when it's 180 minus the 12.1 and 360 minus that 12.1. So this gives me that theta is 167.1, sorry, 0.9 and 347.9. So just listing my angles, so 57.1 degrees, 168 degrees, 237 degrees and 348 degrees, and these I've done to 3 significant figures. So if you've done it more accurate, that's still correct. Okay, so 4 answers. Okay, next question. Sine 2 theta plus cos 2 theta equals 1. Now we have a few ways of solving this one. First, let's use sine 2a to change the first one. So 2 sine theta cos theta plus. Now I think it's easier to do this one with 1 minus 2 sine squared theta. And the reason is that I can see that then the 1's will cancel. So I've got 2 sine theta cos theta minus 2 sine squared theta equaling to 0. Now, again, I need to be careful here, make sure I'm factorising. So I can factorise out 2 sine theta. These with cos theta minus sine theta equals 0. So 2 sine theta equals 0, or cos theta minus sine theta equals 0. So we've got sine theta equaling 0 on this side, and we've got cos theta equals sine theta. Dividing by cos, we get sine theta over cos theta, which is tan theta. So thinking of my answers for theta here, we would be looking at 0, and then we'll be looking at 180 degrees, which is pi, and my theta over here is 45 degrees, which is pi by 4 radian. And that's a very straightforward question here. So very similar to the last one, we've got 8 sine 2 theta plus sine theta. If I use my double angle formula, sine 2 theta becomes 2 sine theta cos theta plus sine theta. So we're left with 16 sine theta cos theta plus sine theta, and then we need to factorize. So in this case, we can only take sine theta outside, leaving 16 cos theta plus 1. So you can see that A is equal to 1, B is equal to 16, and C is also equal to 1. Part B, hence, so remember when you see hence, it means that your answer to part A or the previous part will help you. So we need to solve 8 sine 2 theta plus sine theta equals 0. So that means I can replace it with sine theta bracket 16 cos theta plus 1 equals 0. So sine theta equals 0 and 16 cos theta plus 1 equals 0. So for sine theta, our answers are at 0, 180 and 360. And then for my second one, so we rearrange and we get cos theta equals minus 1/16. Therefore, in the calculator, I'll get a negative angle. So I like to use the positive one for the acute angle, which is 86.4 degrees. Cos is negative, so it's these two sections I want. So I want 180 minus 86.4 and 180 plus 86.4. That will give me 93.6 degrees and 266.4 degrees. And there are all my answers. So number 4, prove sine 3a equals that. So let's start with the left hand side, sine 3a, and I want to write this as an addition angle, so 2a plus a. So this is going to be sine 2a cos a plus cos 2a sine a. And then I need to sort out my two double angles here and here. So sine 2a is 2 sine a cos a, and that's multiplied by cos a plus. And now when I look at the cos 2a, I have a few options, and since everything up here is in terms of sine, I want to turn this into terms of sine, so I'm going to use 1 minus 2 sine squared a, and then that's multiplied by sine a. So we've got 2 sine a cos squared a plus sine a minus 2 sine cubed a. Now I've got left to get rid of this cos squared. So if you think back to your sine squared a plus cos squared a equals 1, then cos squared a is 1 minus sine squared a. So that's what I can substitute in here. So we have 2 sine a multiplied by 1 minus sine squared a plus sine a minus 2 sine cubed a. So this gives me 2 sine a minus 2 sine cubed a plus sine a minus 2 sine cubed a. Now you can see we're pretty much done, so collecting my like terms gives me 3 sine a minus 4 sine cubed a, which is the right hand side. Thus I've proved it. Just a quick pause there. If you are finding these videos useful, please consider subscribing to the channel, as it does help me out. And if you want to see additional other content, anything else, just comment down below. Anyway, let's get back on with it. So first thing we're going to look at is that this is very similar, sine cubed and sine cubed and sine. Difference is this sine cubed is negative and this one's positive. This sine is positive and this one's negative. So there is very much a similarity there. And look, multiples of each other. Now, 20 sine cubed x minus 15 sine x plus 3 equals 0 is my equation. If I factorize out to 5, I would get 4 sine cubed x minus 3 sine x plus 3. This is now very similar to up here, just the opposite signs. So if I actually take a negative out, so negative 5 is one taken outside, I get 3 sine x minus 4 sine cubed x plus 3 equals 0. Now, what's inside my brackets is exactly the same as this. So I can replace that with a sine 3a. So we get minus 5 multiplied by sine. Now instead of 3a, it would be 3x plus 3 equals 0. Now take in, or add in 5 sine 3x gives me this, and then dividing by 5 means that I get that my sine 3x is equal to 3/5. Now before I go any further, I do like to change this 3x into something else, so I'm going to use y. Equally I could have used theta, it makes no difference. Next I need to think about the domain. So we know that x is between minus 60 and 60, so 3x is between 180 and minus 180. So I should be picking up quite a few answers here. Now sine y is 3/5, so my initial value of y is 36.9 degrees. Now what I'm going to use now is just back on my cast rule or method. We're looking at 36.9 degrees, and sine is positive in these two sections. So my second answer is 180 minus 36.9 degrees. Now let's just make a little bit more room. That's better. And this value is 143.1 degrees. So there's my first two values. Now, my second value is when I'm looking in the negative direction, because at the moment I've done between 0 and 180 for y. Now I need to go from 0 to negative 180. Now, looking at this, we've got, as we said before, 36.9, and here is my cast. And if I look from 0 to negative 180, I'm going in this direction, and we know that sine is positive, so it should only happen in these two sections, so there are no solutions between 0 and negative 180. So now I can say that my initial solutions of y are 36.9 degrees and 143.1 degrees. But remember that y is equal to 3x. So really 3x equals these two answers, or these two values. So now I need to divide by 3 to get my two solutions. Now it's always worth keeping your full answers into the calculator here, so that you're not using rounded values. In this case I could have just rounded these values and I should have got the same answers, but that won't happen every time. You could be just one off with your decimal if you use the rounded answers. So you should always use your full answer in your calculator. Don't forget to use that store function. So with this one, part A, we want to start off with this left hand side. If we want to do the show that. And we want to get rid of that sine squared initially to get it in terms of cos, and then we'll be able to turn it into a cos 2 theta. So I know that sine squared can be replaced by 1 minus cos squared theta. And then this gives me 5 minus 5 cos squared theta minus cos squared theta. So 5 minus 6 cos squared theta. Now if I think of my cos 2 theta is 2 cos squared theta minus 1. And if I rearrange this, I get cos 2 theta plus 1 equals 2 cos squared theta. Now I can divide by 2 to get a half cos 2 theta plus a half and substitute in, or I can substitute in as it stands. But I'll do it the halfway for today. And then this will give me 5 minus 6 lots of a half cos 2 theta plus a half. And what I was talking about, and I'll do this in blue so you can see, is that if I'd taken it from this point, I could have gone 5 minus 3 lots of cos 2 theta plus 1. Okay, so I did have a couple of ways of doing it there. So we have 5 minus 3 cos 2 theta minus 3 gives me 2 minus 3 cos 2 theta, which is my right hand side as required. Now for part B, I'm sketching. So y equals 5 sine squared x minus cos squared x can be written as 2 minus 3 cos 2x. So this is what I'm drawing here. So it's a cos 2x graph which has then been stretched by a factor of minus 3, and it's been translated by a factor of 2 there in the y direction. So this will look like, you can see it's between minus 1 and 5 in the y-axis, and from 0 to 540 degrees in the x-axis. Now we've already seen one a bit like this before. You can see cos cube theta minus cos theta. So it's very much the same. You can see if I take a factor of 2 out and get 4 cos cube theta minus 3 cos theta equals root 3. Inside my bracket can then be replaced by the cos 3 theta. Divide by 2, I get cos 3 theta equals root 3 over 2. Now I need to be careful about my domain. It is going to be between 0 and 540 degrees. And like I've done before, I like to change, let's use x this time, to avoid mistakes. So cos x equals root 3 over 2. So x is going to equal 30 degrees. Looking at my cast diagram, 30 degrees is there, cos is positive in these two sections. So we've got 180 minus 30 as my second angle, and then I've got 180 plus 30 as my third angle. So it's the first section, then that third section, and then I go around again because this is all the way around to here. 540 is what I wanted. So 1.5 turns. So this gives me x being 30, 150 and 210 degrees. But obviously that's x and we want theta, so 3 theta would have equaled these degrees, so theta is going to be 10, 50 and 70 degrees.